Digital twin is not only replica of physical model, it is more than that. Digital twins consist of many different features enabling different things, and linking them efficiently together provides the real benefit of the digital twin concept. Instead of the messy grid-style structure, the digital twin features are linked together via a data link. Data link simplifies the interface structure by enabling a star-style structure, and this way, DTs may consist of various software systems implemented in monolithic or microservice-based architecture styles, or a combination of them. The data link also connects multiple digital twins together to form a network of digital twins. The realization of the network of digital twins will be a major worldwide effort, and the rewards will be similar to how the World Wide Web has revolutionized the world. What can you do to make the digital twin web happen?
Thanks to reality animation, they made that happen in 2 weeks. Yeah, that video had quite a lot of stuff, and I'm going to go through them in this presentation. So, my presentation headline is what is a digital twin. I had this headline also in one of my last slides last time also, but I think it's quite a good question. And this presentation is based on the article, a feature-based framework for structuring industrial digital twins. It's in IEEE Access Journal, and it's very accessible. It's early access and open access. So it's available openly if you want to see that. And you can see references there. I don't have those in this presentation. So contents of this presentation, 5 questions. I will go through them, but not right now. Main message is kind of understanding what is a digital twin. So let's start with that. Digital twin is a virtual entity that is linked to a real-world entity. And each of those virtual entity, it is something in the cloud, something digital. We can't kind of elaborate any further than that. That's what it is, and then the path kind of diverges forward from that. Then it is linked somehow. It can be via IoT devices or any other way. Even kind of if there's a human updating the digital twin, it is some kind of digital twin, and there is some kind of link, but it's not very handy. And then it's a real-world entity. It can be a physical product. That's what we have had mostly until now, but there's also already, for example, digital twin for organizations. It's available somewhere. And going from that definition further, the digital twin consists of various features that are selected and customized to serve the needs of diverse use cases. And here are the features. I'm not going deep into those this time. I had them in the previous presentation, and I have modified them a bit since last time. Then we found out are the features independent from each other. We made correlation analysis on that, but our number of samples was a little bit too small to make any final conclusions. Maybe the high amount of correlation between AI and analysis, is, kind of the most alarming. in this, and we need further investigations for this. You can check the slides later. Then, next question, how to compare digital twins? I'm proposing a 5-step method for comparing digital twins, and this is based on the feature division. So, first step, identify the features that you want to include in this analysis. Then define grading methods. I have one grading method. It's very subjective grading method in my paper from 0 to 3. Just what is the presence of features in each article. Then assigning grades based on the grading method for a single digital twin implementation. Then defining weight factors and scale. They are used to calculate the holistic score. It's kind of just one number how good digital twin is, and it is calculated. Actually, this is very simple formula. It looks scary, but it's very simple. Really, it's just sums and multiplications. And then here is how we kind of looked at 7 digital twin implementations found in academic literature, and that is how much presence we found from those. So coupling is most present, which is quite good for digital twins because it's kind of written into the concept. Coupling means that the kind of link between the physical and the digital. Then we can see that security is not yet considered in digital twin literature, at least in these 7 cases. Artificial intelligence is starting to rise, maybe more in the future. Then we can show these numbers in these kind of feature profiles. So what kind of digital twin are we having here? There's kind of six different kind of profiles. So each of them, the articles, they emphasize different things. Then, how to build digital twins. I'm suggesting also a procedure for this. This is a general procedure for any kind of digital twin, and it also builds on the features that I'm suggesting. Then it's also bringing digital twin blocks concept. So first, define requirements. What kind of digital twin do you want to do? What you want it to achieve? Quite basic stuff in engineering. First, define requirements. Second, determine digital twin features based on the requirements. So select just conceptual features. This is kind of a midway step, because then next third we select digital twin blocks. And the digital twin blocks, they are concrete software kind of blocks. They're software, you can use it, and many of them implement kind of different features, and some of them implement many features. But when you have defined your digital twin features, you can see what kind of digital twin block you need, and then it's easy to select what software to use. Okay, that's the kind of defining the first three. Then next step, when we have the digital twin blocks, when we kind of start actually making the digital twin, then if we have done kind of things well, we can just configure the digital twin blocks as the fourth step, and fifth, then just deploy and put it to use, make it live. And then constantly, when you're doing this, build a digital twin class so that you can easily do the same steps again. Kind of a click of a button, you have a new digital twin. Probably you need to configure, but basically the first three, it's very difficult to automate, but the steps 4 and 5, you can automate them quite easily. Then further, how to build digital twins right now. Currently we have these monolith programs, product lifecycle management, ERP, CRM, IoT platform. They are old programs, but they have APIs. So you can connect the systems together, and many companies have done that already. Many companies have integrated PLM and ERP together through some kind of API. How many of you know what API is? How many of you have heard of it? Yes, almost everybody. Nice. Another way of doing things, make it with microservices. How many of you have heard of microservices? Most, yeah, good. I won't explain it deeply, but build one microservice for one digital twin, basically one digital twin block. So these squares, they represent a digital twin block. But you can also combine them, of course, as we saw in the video. Combination of monoliths and microservices based digital twin blocks. And of course, microservices, they are used in many different ways. They are kind of, when you turn a monolith into microservices, it may look like from the PLM you turn it into this, but there is many ways you can do that. Then, why data link? So, the very basic idea, it's just based on numbers. It's the grid style structure that we are now doing. It's messy. Just simply, there's seven different blocks, and that creates the maximum of 21 APIs, and it grows larger. If we have the star style structure, then we have as many APIs as we have digital twin blocks. And at this point, I would like to remind that we have not yet implemented this data link yet. These are concepts, and I'm willing to develop the concepts into concrete things. So, but some companies, they provide some products that kind of give these features that I'm showing here. All right. Another reason to build a data link, to enable the digital twin web. So this is not included in my paper. This is new stuff in this presentation. I have discussed it with some people, but now I will explain a little bit. So it's basically the same as network of digital twins, but I want to make it closer to the World Wide Web. So currently we have the situation of the upper balloons. We have the World Wide Web connected to the real world, and again it's messy. We have this table here, where can we find information about this table? We don't know, it's quite difficult. We would have to kind of check who's the manufacturer, or then take a picture with, and Google is quite good, and Google image search is quite good. But basically, usually the link between World Wide Web and the real world, it's not very feasible. So the lower balloons, 3 balloons, have the digital twin web, and the digital twin web connects the real world to the World Wide Web. And here we can see that the links between World Wide Web and digital twin web, it's not messy, they are straight lines. And between digital twin web and the real world, it's very easy to understand. What's the magic? The magic happens in the digital twin web. There we have this kind of mess we have here in the data link. And basically, I have written it here. Digital twin means semantic linking between real-world entities and the resources of the World Wide Web. Right. But this is work on progress, so let's see what we get here. So the last question, I'm asking you, each one of you, what can you do to make the digital twin web happen? You can share your ideas at dtw.fi. But please also concentrate on the other presentations. And here is the reminder, what is a digital twin? Combination of features. Okay, thank you for listening.
Thank you, Juuso. It's quite difficult to see, but there's still some time for questions if there's anyone who wants to ask Juuso some details. I see one hand.
I'm Ville Lämsä from VTT. So one question about the data link and the star structure as a centralized kind of a structure for this digital twin web. Then on one of the first slides there was this different, in here.
Yes.
This security have quite low number. So your comments on that kind of a star-like structure and the data security, is that an issue, and how to deal with that?
Actually, why the security is low in here, it's because just the digital twin is new term, and the security guys haven't just used it. So there is good opportunities to make security well, and it's very possible to do this in a secure way also. So I don't see a problem in that.
Tatu Koljonen from Aalto. You have this HS score there. What do you use it in practice for, or have you used it for, and what should be its use?
It's basically writing the article. It's kind of started from the urge. How can we compare? Can we make a similar comparison to digital twins as we have to autonomous vehicles? So from 0 to 5. And I wanted to give one number for one digital twin. So basically, it gives one number for one digital twin. What happens in between, it's defined in this method, and it defines the number. So currently, this is a subjective method, but there's room for improvement.
And you foresee the use for that is what?
So I see the use for that. It's if we want to compare digital twins. I'm not sure. This is just, I'm throwing the idea.
Simo Säänevirta from ABB. Have you considered the industry standards that are today kind of already in place when looking at these type of integrations? And I somehow get a feeling that you painted quite a kind of let's say a picture which is showing that we are in a messy situation, whereas we already have, for instance, modeling standards and integration standards that could be used to address these things. So, for instance, OPC UA related developments or description of modules with modular automation concepts and so on. Have they been considered in this development?
Yes, I'm very familiar with OPC UA, and I think it's very good in what it does, but this is doing different thing. So, yeah, but this is a very good question.